Okay, hello and good morning. Today I will be demonstrating how to create a logic gate, specifically the OR logic gate, using two transistors, specifically the NPN transistors. So for this demonstration, first I will showcase the parts that I will be using. Next, I will be assembling it. Next, I will explain why it's particular like that. So for example, first I got my power supply. Both the positive and negative lead already plugged into the breadboard. I have two 3904s. These are NPN transistors right here. Got two of them. A 1K resistor, and finally some one LED and an assortment of jumper cables. So let's go right in. So how a logic gate works is either one of the inputs to the gate has to be 1 in order for there to be an output of 1. So to do this, these two will act like switches. If current passes through either one of them, it will be considered a 1. If no current passes through it, it will be considered 0. Now you can use this as a switch by inputting a current through the base. If there is a current going through the base, it will allow current to flow through, which makes it a 1. If you do not put any current through the base, it will not allow any current to pass through the collector and emitter, so that will be 0. So you can essentially add a switch to the middle leg and just turn it on or off to make it do either a 1 or a 0. Okay, so first what I'm going to do is I'm going to assemble the diode for the transistor first. So with the rounded portion facing me, I'm going to put it here in my breadboard, just arbitrarily put it here. So one leg will be there, one leg will be there, somewhat like this. So here, that is the collector, the middle leg is the base, and the last leg is the emitter. I will do this for, I'll just place it here so that I have more space for my jumpers. There. I'll do the same, but I'll do it on this row here. I'm going to line them up just so they look symmetrical. Now we're going to take one of the jumper cables. One of them, I'm going to put it right here next to the there, and this will serve as our collector. Put the collector right here. I'm gonna do the same for the other one. I'm gonna take another jumper cable. I'm gonna put it right here next to the okay. That one doesn't like me. I'm just going to get the other one. Fix this one and plug it the same way I did for the first one. Alright, now for the emitters. I'm going to take two of these. One at the emitter, right here. You can't see right there. On its leg, the third leg, same row as this leg. Right here. And I'm just going to put it right somewhere here. I'm going to do the same for the other one. So, same row as the emitter leg. Just put it right beside there. Now we got the emitters all nice and ready. Now I'm gonna get a load. So for my load, it will be this 1K resistance, 1 kilo ohm resistance, and coupled with this emitter, this LED. I'm gonna put the leg right here on the same row as these two emitters. That, and just to save some time and space, I'm gonna take the LED and I'm just going to plug it straight into the ground. Just right here. finally, we're going to take 2 jumper cables, and then we're going to set up our base. So since this is the base, it's going to act like the switch. I'm gonna set it far away from the rest so that I can easily yank them out. That way I can demonstrate the 1 and or 0 operations. So where did I put the... So I put the first part of the jumper cable on the same line as the positive terminal. I'm going to take its other end and I'm going to put it in the same row as the middle leg of the transistor. There you go. I'm going to do the same for the other one. Just a little far away from the rest so I can easily yank these out. Same leg as the third, same row as the third leg. There we go. Alright. Okay, so for some explanation, these diodes, they will only allow current to pass through if there is current passing through the base. So as you can see, the collector here is collecting current from the positive and it goes to the transistor. The transistor acts like a gate. It will only allow current from the collector to go to the emitter if there is also current passing through the base, which is why I also connected the base to the positive. Now, in theory, if I turn this on right now, this should light up because it's a OR gate. So in theory, an OR gate is, as long as either of the inputs is a 1, this will also light up. Since these are both plugged in, this should light up as well. The only time this will not light up is if I pull the plug on both of the base jumpers. Alright, so to demonstrate and to show you that this thing works, I will now show you the 4 inputs. So now I will take my DC supply and I will set it to 5. Alright, I'm gonna set this thing to 5. And as you can see, it's lighting up. I'm gonna turn this light off so you can see. There, it's lighting up. This is the first input. So since current is passing through both of these both these transistors, because I plugged them both to the base and the base is plugged in with current, it will act as both 1 on this one and 1 on that. So 1 and or 1 is 1. Now to demonstrate the second input, which is 1 and a 0. So in theory, if at least 1, there should be at least 1 input and it would still output a 1. So I'm going to yank out. So this is this cable here. This is the base cable for this transistor. So if I yank this out, this should still be a 1. Ergo, there should also be, the LED should be lighting up. So I yanked it out and it's still outputting. So this is the 1, so 1 0 input. Now what about the other way around? So what about I make it 0 1? My goodness. So what if I make it 0 1? So I'm going to pull the cable on this here, so it will demonstrate that yeah, it still does it, it still lights up. Now that's the third input, which is 0 0 for this transistor, but a 1 for this transistor. So the final output should be 0 and 0. So this is the only time that this diode will not light up. So 0 or 0 is a 0. So I'm going to pull the plug on this diode, on this base, and voila, it doesn't turn on. So 0 or 0 produces a 0. So thank you for watching my demonstration of a logic gate using transistors. Thank you for watching. I'm going to turn this off now. And thank you.